All right, let's talk about something that feels like it's on all of our minds lately: extreme weather. Today, we're going to connect the dots between the wild weather we're seeing and our changing climate. We'll dig into the science, look at the real world impacts, and most importantly, talk about what we can actually do about it. So, let me just start by asking a question. Does it feel to you like those once in a lifetime storms or heat waves are, well, not so once in a lifetime anymore? Whether it's seeing news about record heat, devastating floods, or those massive wildfires, it kind of feels like the whole rhythm of our weather has shifted, right? Like these unprecedented events are becoming the new normal. Well, it turns out that feeling you have, it's not just in your head. It's backed up by some serious science. What we're all experiencing isn't just a random blip or a run of bad luck. It's actually a new reality, a pattern of weather on overdrive, all fueled by deeper changes happening in our climate system. And look, we don't even have to guess about what's causing it. The Intergovernmental Panel on Climate Change, the IPCC, which is basically the world's leading authority on all things climate science, they put it about as bluntly as you can. They say the link between our emissions and more extreme weather is an established fact. That's about as certain as it gets in science. And this pattern plays out in a bunch of different interconnected ways. We're talking about more intense heat waves that just bake entire regions. We see longer, more punishing droughts that completely strain water supplies. And then, crazily enough, those droughts are often followed by these sudden, massive downpours that cause flash flooding. All this extra energy also creates the perfect conditions for more powerful storms and bigger, more destructive wildfires. It's a whole global cycle of extremes. So the big question is, how can scientists be so certain about this connection? Let's peel back the layers a bit and get into the science, because it's pretty fascinating how they've managed to identify the human fingerprint on our weather. The basic physics here is actually pretty straightforward. Think of it like this. Ever since the Industrial Revolution, we've been pumping greenhouse gases into the atmosphere. These gases act just like a blanket, trapping heat from the sun that would otherwise escape into space. Now, all that extra trapped heat doesn't just bump up the average temperature, it adds a ton of extra energy that supercharges the entire climate system. Okay, but this brings up a really important and very common question. When a disaster hits, we all want to know, was this specific storm caused by climate change? And the answer, you'll see, is a little more nuanced than a simple yes or no. To answer that question, scientists have developed this incredible field called event attribution. It's not really about proving that climate change caused a single event to happen. Instead, it's all about calculating how much human influence has, loaded the dice, making certain extreme events more likely to happen, or way more intense when they do. Here's how they do it, and it's brilliant. They use these super powerful computer models to simulate two different worlds. The first is a world that could have been, one without all of our greenhouse gas emissions. The second is the world we actually live in today. By running thousands of simulations, they can see how often an event, like a monster heat wave, shows up in each of those worlds. And by comparing those two scenarios, they can make these incredibly specific, data-backed statements. They can literally quantify the human fingerprint on an event. They can tell us, for example, that climate change made a particular heat wave 15% more intense than it would have been, or that it made it twice as likely to happen in the first place. But the story doesn't stop there. The problem gets even more complex, because the risks aren't just from single isolated events anymore. We're now seeing disasters start to overlap, creating what are called compounding crises. So let's just walk through an example. Imagine a region that's already been suffering from a really long drought for months. The ground is parched, the reservoirs are low, and all the vegetation is basically tinder dry. Okay, now on top of that already bad situation, you add an intense, record-breaking heat wave. That combination, the dried conditions plus the extreme heat, creates a much, much bigger disaster than either one would have on its own. It massively increases the risk of explosive wildfires and can cause absolutely catastrophic losses for farmers. And that's just one example of what scientists call a compound event. Think about a storm surge from a hurricane hitting the coast at the exact same time as extreme rainfall, leading to insane coastal flooding. Or imagine multiple major farming regions around the world getting hit by heat waves at the same time. That could seriously threaten the global food supply. These overlapping disasters can just completely overwhelm a community's ability to respond. Now, I know this picture can seem really bleak, but it's so important to remember this. The science doesn't just define the problem for us. It also points us toward the solutions. It shows us the path forward. So here is the most crucial point of all. The future is not set in stone. The science is crystal clear that how severe things get depends directly on the choices and the actions that we take starting right now. The response really comes down to a two-pronged approach. Think of them like two sides of the very same coin. On one side, you have mitigation. That's all about tackling the root cause by cutting greenhouse gas emissions to stop the problem from getting worse. And on the other side, you have adaptation. That's about managing the impacts we're already locked into by preparing our communities for this new climate reality. Building that resilience involves very concrete steps. It means we have to rapidly switch over to renewable energy sources. It means investing in better disaster warning systems so people have time to prepare. And it means fundamentally rethinking how we build our cities and our infrastructure so they can actually withstand the climate risks of the future. Listen, the world's leading climate scientists have laid the stakes out for us. They've told us the evidence is unequivocal. The challenge is huge, no doubt, but they also make it very clear that there is still a window. A rapidly closing one, sure, but still a window to act and secure a future that is safe and livable. So that's where we are. The science has given us the diagnosis, and it has pointed us toward the treatment. The story of our climate future is still being written right now. And the defining question for all of us is pretty simple. What role are we going to play in writing it?